remember this is 234 here, so this plus this has to equal 234 on that side also.
230.
So 230, and I have 90 here, so what plus 2 will give me 90? All right, so what element do I have? What do I look up, the 230 or the 88? So what up there has 88? Radium. Okay, so radium. All right,
Wait, where exactly do we look at the 88?
You look at the atomic number. So you look on your periodic table, and you find the element that has atomic number 88. Okay? Now, what?
Look at the bottom number?
Or the smallest number. It may not necessarily be the bottom, but it's always the smallest number. All right, what if they asked you what type of radiation it had? How would you know what type of radiation it has?
For the H's.
It's right here. Tells you it's what? That tells you it's alpha. All right. So if I do the bottom one, all right. Oops, I had glue there. What do we do?
224.
All right. So again, you have what here? 244. So what plus 0 will give you 244? So did everybody see how Betsabé got that? All right. So on the bottom, what do we have? All right. Got a -1 down here. So what plus -1 will give you 94? 95. Everybody see how they got 95? All right. So what element has 95 for an atomic number? All right.
Where were the 90s at?
Down at the very bottom. All right. So what kind of decay do you have here? Beta. Everybody got it?
Wait, how do you know it's beta?
Because it has an E. Remember a minute ago when I asked you the symbols?
Oh.
Remember that? So anything that had the H, E with the 4 and the 2, that tells you it's alpha decay. And anything that had an E with the 0 and the -1, that tells you it's beta decay. Right? Anybody else? Question? Anybody? All right. What did we not finish going over that we were practicing with on Friday? Because I'm doing this in 2 classes, so I don't remember. I gave you 2 worksheets, and I do not remember what we did and didn't go over from Friday. Did we finish the ABG worksheet with the blank lines? Did we go through all of those?
No, I don't think we went over the things of
I got two equations in the.
What?
What's not mine? I'll be in the. It's Miss B's class, right?
Hurry up. How are you? You lose your hand. It wasn't attached. All right, so if we look at the one that's got the A, B, and the G, real quick then. All right, I know we were talking about, because I remember drawing it on the board. So if we have the one that had the magnet plates, because I remember drawing the little positive plates on the board. All right, if we had particles that went through. If we have a gamma particle that goes through, okay, does gamma have a charge? No. So gamma has no charge. So will it go towards the positive or the negative, or will it pass straight through? It will pass straight through. It won't go either direction, right? Now, if I have a beta particle has what charge? It's a negative particle, right? So a negative particle is going to go towards a what? It's going to go towards the positive because opposites do what? They attract. All right. Now an alpha particle being a positive particle will go towards the what? That's going to go towards the negative. I remember talking about that. So if we run through these again for those people who are not here. And those of you who are not here, this stuff, Bryce, get off your phone. Put it away. Now, if we look at the stuff that you have in front of you, All right, even though y'all were not here, this is some of the easiest stuff you guys should be able to get right on the exam. Which one is not deflected by the magnetic field based on the picture we just drew? Gamma. What one was the weakest type of radiation based on what we just went over? Alpha. When it passes through the magnetic field, who is deflected towards the negative? All right, towards the negative would be the alpha because we said it's going to be a positive charge goes towards the negative. Who is formed? This is just the definition. Who is formed when a neutron breaks apart in the nucleus? That's the beta particle. That's the definition of a beta for those of you who are absent. When it's passed through a magnetic field, it's deflected towards the positive pole. Who goes towards the positive? That's the beta because it's negative. Who's the most penetrating type of radiation? That's gamma. That's the most hazardous of all three types. Who's a helium nucleus? That's alpha. That's the definition of an alpha particle. Who is the electromagnetic wave? That's gamma. That's its definition. Who can be stopped by a sheet of paper? Alpha. Who has 2 protons and 2 neutrons? That's alpha. That's its definition. Who is an electron? Beta. That's its definition. And the last one, who can be stopped by several centimeters of lead? That's gamma. Okay? That was the one I thought we went over. I wasn't sure though. All right. And I told you to do like what? 1 through 6 on this?
Yeah.
Something like that. All right. So if we look at the first one here. Because if you can do 6 of these, you can do the whole paper. We're not doing this whole paper. We don't need to do the whole paper. There we go. There we go. Is that big enough you can see it, Alicia? You see that back there? All right. So if I got 214 on this side, 210 plus what? 4. 82 plus what will give me 84? Which means that's HE. What kind of radiation would we have there? Alpha. That says 222. So what plus 4? 218. 2 plus what will give me 86? What element has an 84? PO. So polonium. What kind of radiation do I have there? Alpha. Number 3, we've got RA. So 226 plus what will give me, what is that? 230? So 4. 88 plus what will give me 90? So that'll be a HE. So that's again alpha. I've got 214, but I've got a 0 here. So I'm going to have what here? 214. Negative 1 plus what will give me 82? So I'm going to have what? BI? And then this one, I've got 4 plus 222. 2 plus 86. And what do I get here? RA or RN? RN. I thought y'all said RN and I wrote RA. All right. So number 6, the last one. What plus 220, 239? Is that what that says?
Yeah.
And then 94?
Yeah.
And that's what? PU?
Yeah.
All right. This last one, number 7, real quick. What do you do if you have the line on that side? You just add them together. Okay. I just want to make sure we were all together. So that's what? 238? And 92? And a big U? All right. The last thing I would point out is, remember when I told you gamma? A lot of times they just write plus gamma. Does that create any issues if you had to fill in that line? No. You don't do anything different. Everybody okay with how to do those? Fabulous. All right. The last thing we have to do today is talk about half-life and fission and fusion. Okay? And then we're going to talk some acids and bases. And then we're going to move on towards review. What is it?
Check homework.
Hmm?
Check from.
Oh, stick it over there on my desk. Yeah, that was the last thing I checked. And y'all will need a calculator for this last math thing, so if you want, grab a calculator. Yes, go ahead. I don't want to deprive you of an opportunity to ask me to go to the bathroom again today.
Hey, bro.
Ah.
Oh, if there are any that are dead that y'all come across, I have batteries now. I don't like the taste. I know. Everybody in my family does. I don't like the taste. Alright. So we're going to talk half-life for the next couple minutes. Alright? You may have talked about this in earth science, but I don't know if you did or not. You should have.
What's our slide?
It's a class you took as a 9th grader. Now, half-life is the amount of time it takes for 1/2 of a substance. Let me not say substance. I'm going to change that. All right. It's the amount of time it takes for 1/2 of a radioactive material to decay into a stable compound. I like that better.
That's all you do.
What? All right, we caught up?
No.
Yeah.
All right, we're going to start with 100 grams. And this is, and I'm just going to write in here, radio.
My two, I have.
Huh?
That's a half.
Yeah, half. Okay. Okay, so we got 100 grams of some radioactive stuff. We're going to say that its half-life is, let's just say that it's 15 years. Okay? That's its half-life. Now, after this 15 years goes by, what's left? All right. Now, the law of conservation of mass says what? Mass is what?
Oh, matter if you're not.
That's right. So I still have how much left? 100. So, After 15 years, 50 grams is radioactive because half of the radioactive material becomes what? Stable. Okay? So 50 grams is radioactive and 50 grams is stable. So what a half-life means is after that 15 years goes by, half of that material decays into something that is stable, but you still have half of it that's left is that radioactive crap that's poisonous, that's bad for the earth. Now, after another 15 years goes by, what happens? That's what some people think. It splits again. That 50 grams splits again. So now 50 grams has split again, and that 50 becomes what? 25 grams is now radioactive. And so 25 now becomes over here with a 50. And so I now have how much that's stable? 75 grams is now stable. Because remember, I started with how much? 100. So as this stuff decays, I always have how much? 100. It never changes. The law of conservation of mass says matter is not created or destroyed. So if I start with 100, I keep 100. It doesn't go away. So if another 15 years goes by, all right, and it splits again, that 25 does what? It splits, and I have how much now is radioactive? 12.5 grams is radioactive. And that 12.5 goes over here, and I'm at what? 87.5 grams is stable. So, over time, this continues to happen. Does the nuclear stuff or radioactive stuff ever completely go away? Well, sort of. All right, but there's always going to be some minute or trace amounts. Now, envision your uranium or your plutonium or the stuff we use to make nuclear weapons or nuclear power plants that have millions of years for half-lives. Is that stuff ever leaving the planet? No. Okay? It's always here. We're storing it. We're praying we don't have a leak. We put it in cement, concrete, lead containers, and we store it. Okay? It's always going to be here. Not going anywhere. Now, we have to be able to calculate a half-life if they ask us for one. So here's a typical sample problem. I'll give you a minute to write it down, and then I'll show you an easy way to calculate it. Some of you may know an easier math way. Fabulous if you do. I'm going to show you how to do it in a different kind of chart.
Yeah, right.
Yep.
But they did, so they did. But that's really like to do this every year. I'll see it here.
You got it written down? I'm on.
All right, please, 125.
All right, we got it? Now, the way I usually show this is by drawing a T-chart this way. Okay, lots of different ways you can go about doing it. Doesn't really matter. If you see a different way in your head, then do it a different way. Okay? Time and amount. And then this is just a visual way to organize the information. All right? Now, on this side, time, and on this side, amount, and you can flip it. It doesn't matter to me which way you do it. Time always starts at 0. And how much did I tell you in the question I'm giving you for an amount? I told you in this question that I'm starting you with an amount of what? 50 grams. Now, the definition for half-life, all right, is that we're going to divide the amount by what? You're going to divide by, of course, half. So you're going to divide by 2. And over here, the time, you always add whatever the half-life is. Okay? So in this case, what did I tell you the half-life is? 25 days. So for the time, we're going to add 25 days. So if I add 25 days, so after 25 days has passed, how much is left of my 50 grams? 25 grams. Now, if that's how much I wanted to know, after 25 days, I'd have 25 grams left. I would be done with the question. Is that what I asked you in the question? No, I wanted to know how much is left after how many days? 100 days. So I have to keep going in my chart. So add another half-life. 25 days was the half-life, right? So 25 plus 25 is 50 days. So what do I do to my 25 grams? Divide by 2. So what's that, 12.5? 12.5 grams. Is that what I wanted to know after 50 days? No. So add another half-life. 25 plus 50 is 75 days. Divide this by 2. What's that, 6.25? 7. Is that what I wanted to know after 75 days? So we keep going. Add another half-life. That would be 100 days. That would be what? 3.125 grams. This would be what the question was asking for. So after 100 days, how many grams are left out of our 100-gram sample? 3.125 grams would be what's left out of our sample. Questions about how I did that? Everybody with me? Yay or nay? Yes? All right. You think you can do one? Calculate. This one I did in seconds instead of days.
Thank you.
All right. I have to put this. It's not there.
All right, guys, be patient. Not everybody works this fast.
That's right there.
Oh.
Go right back.
Sure. I remember, and I could have like stepped back and like, get up. I was a Spider-Man. I was like, I was so scared. Like, the joke was right in my face.
All right, we got it?
Just paid 1,000 on the board. Let's say 5.
On the flex card? See if you get audited. All right. So time and amount. So what's the time got to start at? Got to start at 0, and that's the biggest mistake people make. They forget to start at 0. How much did my sample start at? 10 grams. All right, so what's my half-life in this one? 45 seconds. All right, so in 45 seconds, how much is left? 5 grams. Did that ask me what I wanted 45 seconds? No, of course not. Never asked that. All right, so add my half-life over here. So I get what? 90. What's left after 90? 2.5. Do they want 90? No, it couldn't have been that easy. All right, add 45 again. What's that, 135? And what do I have left? All right. Add 90 again. That's what, 180? What's left over here? 625. All right, add 45 again. 225. What's left? 3125. Is that what they wanted? Everybody got it? Feel good about half-life? All right. The last topic we need to do with nuclear that you need to know about for the exam are fission and fusion. You should have. Fission and fusion should have been in Earth Science. Okay? Tell me what fission is then. Okay? If you can remember what fusion is from English class, fission and fusion should not be hard to keep straight on the exam. To fuse is to do what? Come together. So fission is splitting a large nucleus into 2 smaller nuclei. Okay? It's a splitting of a large nucleus into 2 smaller nuclei. Now, I'm going to show you I'm going to write a nuclear fission reaction on the board and put the real numbers in it instead of making one up. But you do not need to know the numbers for the exam. Where are the numbers? So I don't make it up. It's krypton and barium, but I don't remember the numbers. 92 and 141. All right, we use uranium-235. Use that circle. All right, in the circle, and Alicia, I know this is going to be small for you to see, but it's uranium-235. All right, and we actually strike the uranium with a neutron. Okay, and this little circle is supposed to represent a neutron. All right, so that neutron hits a uranium-235, and I know that's small. Now, when that hits, it splits into 2 smaller nuclei. Now, these nuclei, one of them is krypton, and one of them is barium. Tevin, shut up. Now, the numbers, you don't have to know, but since I'm writing them down, there's no need in me writing them down wrong. All right, krypton I just said, but I forgot it already. That's why I never remember these things. Krypton was 92, and barium was 141. Now, when it makes this, it also makes 3 neutrons. Okay? Now, the 3 neutrons aren't important. The important piece is that it makes a neutron. All right? Now, this neutron that it makes is going to strike another uranium-235. That uranium-235 is going to create another krypton-92 and another barium-141 and another 3 neutrons. Now, one of those neutrons is again going to strike another uranium-235, which is going to create another krypton-92 and another barium-141 and another neutron, which is going to strike another uranium-235. Now, this is important because this is a nuclear chain reaction. Now, this reaction can be controlled or it can be uncontrolled. Now, where would we use it in a controlled fashion? Where would we use this chain reaction in a controlled fashion? A nuclear fission reaction. Where would we use that?
Somewhere you don't get yourself killed.
Well, certainly. We wouldn't want to kill them.
Also, like, you ever see like in a lab or in a lab somewhere? Because like, you know, you control like control like
But you mean like control or like?
Where would we use a controlled fission reaction?
Sure. Sure.
Yes, but I'm thinking more practical. Yes.
Mercury.
I have 3 of them in the state of North Carolina.
We have 3?
What?
What like nuclear reactors on some?
Oh, really? We do?
I didn't even know we had.
What do we use them for?
Electricity.
Mm-hmm.
LGC.
Use them for power plants, for electricity.
I think I'll see.
What happened, man? I've never seen.
Should be one somewhere outside of Raleigh, one outside of Charlotte, and one outside of Wilmington.
Yeah.
All right, where would we use it as an uncontrolled reaction?
Hiroshima.
There you go.
My people.
To this date, we have only used 2, and both of them were dropped by the United States. Now, there have been a couple nuclear accidents, and unfortunately, those were meltdowns. One was in Russia, and one was here in the United States. All right, Chernobyl was one of them.
He was up in New York.
3 Mile Island. Yes,
3 Mile
Somebody
Island.
did that.
it's in New York.
Oh wait. So people can't go there, right?
No, well, you can go there, but you can't live there or inhabit that area. Okay, and you certainly wouldn't want to hang out there long.
Doesn't that have to do with half-life too? Like,
Mm-hmm. Yes, because the materials that were released during that, of course, the materials have now gotten into the groundwater, and all of that, and that area will not be inhabitable during our lifetime, or probably ever again during our. I would imagine that the Earth will not be roamed by some type of dinosaur or creature again before it's ever able to be lived on again. All right, now fusion. How is fusion different? What does fusion do? Okay, so this will be 2 small nuclei combine into one larger nucleus. Now, this one is going to be two hydrogens, and they come together to form a helium atom. Wait.
I just the way that you put the hydrogen in, I was just like,
Mhm.
okay, what are you adding?
Mhm. What's the matter, Hyra? I said, what's the matter? I don't know. You just look sort of zoned out.
It's a rookie game. And then you gotta go run 2 miles.
I'm bad, I'm sorry.
Why's he gotta go run 2 miles?
Cause it's like, you know, if I
That's all of it.
Yeah.
I see, yeah, this way.
Mm.
You're not gonna run, you go fast.
Hope he wakes up then.
No, man. It's fairly good weather.
You better open that one.
No, that junk is crucial though. 2 miles is crucial.
It's worse.
Trust me, right.
Why you gotta do 2 miles?
It's worse than the gym. Yeah.
Oh, I got that right,
Now
20.
you gonna have to run in the gym if you don't.
That's fine.
All right, everybody got it?
I feel like.
Yes? Nope.
That's just coming on.
I like to try better than the gym. The gym is not equal to the gym.
That track is good.
The gym is terrible. The gym is horrible.
I be running in the gym for a little bit, you hit the track.
Okay, let's go off and you go.
I'm waiting on Rebecca. Is she there? All right. So, tell me some of the advantages of fission and fusion. Why do we use one versus the other? All right. Now, the biggest disadvantage of fission, all right, fission creates nuclear waste. Okay? It must be stored. Now, every time I turn around, somebody's telling me to shoot that stuff out in space. What's the problem with shooting stuff out in space? Well, space is not necessarily radioactive, no, but satellites and everything else we put out in orbit, what happens to it? Anybody know?
Poof, gone.
No, not poof gone.
What do you mean, Jim?
No. What happens to all satellites we put in
They
space?
come back there.
They come back, okay? They're in the Earth's gravitational field, and eventually they get pulled back, and they do crash into the Earth. The nice part about the Earth is it's mostly water, and so most of the time it crashes into the ocean, all right? Most of the time, but periodically it crashes into land, and we've been very fortunate in that most of the time it's crashed into places where it's not very heavily populated, so it hasn't hit anything or anybody. Now, there's always the hazard that it's going to crash into a large city and hit something, okay? So if we blast our nuclear waste into the outer space area, eventually that stuff is coming where? Back. When Chernobyl had its meltdown and all of that radioactive waste went up in the air, it gets caught in the clouds and the weather patterns, and it does what? It travels the globe. Eventually, our cows and our weather rained that hazardous waste into our grass and our air and our water tables. And yes, that was trace amounts here, but we were able to track that into our food supply. So we do not want to blast the radioactive waste into space knowing it's coming back onto the Earth.
What about deep space?
We have no way to get it there. Yes,
Well,
ma'am.
the satellite comes back down, they know when it's coming, right?
Yes, and they try very hard to steer it into some unpopulated areas, yes. Same with the astronauts. They steer that in a way that they know where it's going to land so that it's not going to hit the middle of New York City, yes. Okay? But periodically they do lose control of those things, and so they have to hope that it's not going to land in the middle of a populated area. Okay? Now, what's an advantage of fission? Fission is a controllable form of energy. Okay? We can control this one. Now, that leads us to our conversation about fusion. Now, fusion creates no radioactive waste. Yeah. So most people are like, why are we using fusion then, Ms. Wall? Why are we using fission? Can't we use fusion? It's got no waste. This would be a fabulous way to go. It would be. The problem is fusion is like the sun. Okay? It's like the sun. Extremely hot. Okay? It is not controllable. I can't even read that. That's written so bad. Okay? We cannot control the temperatures that are associated with fusion. So even though it creates no waste, we cannot control temperatures like the temperatures on the sun. And I'm just estimating, but 20 million degrees Celsius, we can't control those here on the Earth. It would melt anything that we would even get close to in terms of a temperature. Now, we could use nuclear fission to create nuclear fusion, but it would melt everything in its path. It is a bad idea. So we can't use that to create any type of energy or harness it in any kind of way that's useful right now. Okay? Questions about nuclear chemistry?
Is that why the topic of cold fission came up?
Probably. I don't know how cold fusion works though.
It's like the idea of getting that fission to the room temperature of 72 degrees. That's not really possible to use.
It would be fabulous if they could make it work. That'd be great. Are they making any headway with that? Oh. All right, we're going to do a short clicker to review nuclear real quick. It's not very long. It's only like 8 or 9 questions. I can't remember. I think it's only 8. It's short. All right, and then we're going to talk a little bit about acids and bases. Not very long at all. And then we're going to, tomorrow, what's Wednesday, Thursday, Friday? We're going to review what we can to try to get y'all ready for exams. Would you?
I have to play.
Yes, you got to play. Go.
Tim, your people.
Miss Wall, are
Yeah.
you gonna be doing any review next week?
I told you I'd review the Monday and Tuesday after exams, and I'd even offer the bonus points after the 4th period exam and after the 3rd period exam, because I'm going to be here anyway. So
Are you gonna do bathroom classes too?
I'll add those in after Friday's class this week.
What number?
I'm pulling it up. If you don't know your numbers. I'm pulling it up if you forgot. Stop writing on that.
It's a sticky note.
I know.
Who is having this thing?
Tomorrow. And every other day after that.
Come, get your clicker card.
What did you just
All right, everybody got their card?
No.
Niggas that say,
You gonna knock that phone off.
hey, niggas they lit. Hey, niggas they lit.
All right. Which list of particles is in order of increasing mass? And I can't make these bigger because a couple of them have diagrams, and I'm afraid the diagrams are going to be too big as it is. So, Alicia, if you can't see your destiny, move closer.
Hold
Because a couple of them, like I said, I'm afraid my diagrams are going to be too big as it is.
on. Let me count these checks. Stone on my head.
Which one's in order of increasing mass, from smallest to biggest?
I remember.
Think about the mass of a proton, the mass of an
Big C's.
electron, and the mass of an alpha particle.
Big C's. I think it's Big B's.
And I'm going to wait on a couple more cards to pop up before I scan.
Kevin.
What?
That's not appropriate.
Hey.
Pay for it, huh?
All right, Joe.
Wait. Okay.
Did I take the page? Oh, you already scanned it down.
Right. So that's it.
No, I don't have yours.
You so lucky. You so crazy.
You're not going to participate? Yes. Are you going to participate?
Oh, yeah.
Get mine already. So. Alright, so we've got 11 rights and 4 wrongs. Alright, so when you look at that, what's the mass of an electron?
0.
The mass of an electron is 0. The mass of a proton. Anybody remember?
No.
Just one. Helium or an alpha particle.
There's 2. Oh, 4? Oh, that's the number.
Okay, so which one's right?
C.
It's C. Okay? So those of you who said C have the right answer. Alright, gotta make this one smaller. I told you I was gonna make this one smaller. Alright, so I told you I was gonna have to make it smaller for some of the diagrams.
Oh, got you.
A is fission, B is fusion, C is alpha decay,
Wait, I'm up.
and D is beta decay. Alright, fission, fusion, alpha, beta. Okay? Fission, fusion, alpha, beta.
Hey.
Number 8 is fission.
Fission is A.
This is what you get me?
Yeah, I think I did. Landry, did I get you?
I held it up.
Okay. Yeah, it was Jennifer I missed. I knew I missed somebody over there. That's it's easier to get if it's not bouncing. I need Salma and Alicia. All right. So we've got all but one. One person got it wrong. What is that supposed to be? That is fission. Neutron strikes that big nucleus and it splits into two smaller nuclei. All right. What? All right, hold on, I can make it bigger. All right, which types of radiation have the greatest penetrating power? Alpha, beta, gamma, or positron? Which one has the greatest type of penetrating power?
Let's say.
What?
I think it's not. What is a positron?
Yo.
My best advice to you on the exam is if you've never heard of it, don't pick it.
Right.
It's E.
I think that's Z.
That's what it was. E. Say E.
Turn it a little bit, Trent. There you go. I got it.
It's K, Trent. K. K.
Destiny, it cannot flop like that.
Jennifer, isn't it K?
All right, I need Rebecca's.
This guy.
I think that's it. All right, so we got one wrong again. The one with the greatest penetrating power is which one?
Yeah.
Gamma. Who's the weakest?
Alpha.
Alpha.
What was it?
It was gamma. Which particle has the greatest mass?
Oh, beta.
Alpha, beta, gamma, or positron?
What is a positron?
It just pops up a lot in the questions. It sounds technical. Like I told you, Samba, if you've not heard of it, don't pick it. Why are you wearing that hood? This Curry's been on a tear about hoods lately.
She's thinking very strong. It's because it's a Manchester Tech.
No, she was
Oh,
yelling
wait.
about hoods long before
I
that.
think that's right. Two to pull off in the jet. Hold on. Hey.
Okay.
All right, I'm missing Destiny. I already got you. I need an answer. Well, I didn't read it. There you go. All right, I got everybody this time. So I got 13 right, 3 wrong. Greatest mass. What's the mass of an alpha particle?
4.
All right, remember, think about their symbols. Helium has a 4 and a 2. Beta has an O and a -1. So that's the mass of a helium. That's the mass of an electron. A gamma had no symbol. It has no mass. So that's out. Y'all don't even know what a positron is. Don't pick that. So it's either alpha or beta. All right, which one is it? It's alpha. All right, this is what I'm going to need to just fix just a little. All right, in the equation, the X represents what? A helium, a beta, a proton, or a neutron?
Oh, I know that one.
I know that one.
Yes, we did. You got to figure out what it is. You got to solve for the X to know what it is.
I got you.
I got it.
Give everybody a chance, and then I'll scan.
And I said that was John. I remember you said that was John, the X.
Huh? You got to figure out what the think of the X as a blank line. You got to figure out what the blank line is. Instead of an X, it's the blank line.
Oh,
Okay? Instead of X, it's the blank line. Okay?
okay, I know what you're talking about. I'm done.
All right. So we got 15 rights and 1 wrong. All right? The 1 wrong, I don't know what they were thinking. All right? When you add on this side, 234 plus what? Remember, this is just a blank line. 234 plus what? 0. 92 and -1 will give you 91 on that side, so that would be an E, right? So it's a beta particle.
Lord Jesus.
Oh my God.
Jennifer, sorry.
Count out these checks. Hold on.
Which type of radiation is most similar to high energy X-rays?
Ooh.
Oh, I know this one.
Which one's most similar to high energy X-rays? Rice. Could you participate?
Wait. Hey.
We're all tired.
We're all tired except Miss Wall.
I gotta go to that.
Who knows the answer?
Oh my gosh.
No.
I swear, we get to go.
I think you did a tough face.
Okay.
Where's your
Okay.
Oh, you told me to my
Boy.
All right, I need Liliana.
Timmy.
Oh.
Bro, I'm glad you said, bro. As soon as you turn it, they just say bing bing.
Jennifer.
I'm right here.
All right. We got 3 wrong, 13 right. When you look at your reference table, who's on there beside an X-ray? Gamma rays. Gamma and X-rays are pretty close to each other on your reference table. They're electromagnetic radiation. All right. Alpha and beta are not high energy waves. All right. Which type of nuclear emission is negatively charged? Y'all better not get this wrong.
Which
I'll get it
nuclear
on for you.
negative?
Thank you.
Oh, I know. I got it.
Come on, try to get it on.
Hey, Molly.
Which one's negatively charged?
Hi, Molly. Oh, it was wrong. My bad. Wait, I thought you said alpha was. All right,
It don't matter. I already got one right.
Wait.
I think you. All right, bro. I can't wait. That can't be me. Yo, hold on. Wait a minute. Y'all thought I was finished.
Yeah.
I don't remember.
Oh, Miss Wall. Right. Dang, I didn't look at it.
0 is negative
You know what?
1.
I didn't actually know
I thought it was B.
Did I get it right?
What is it?
Okay,
B?
good. Did I get it right?
Sarah, I gotta
It's
get
B.
That's the last one.
I put A.
It's F.
Okay, I got it right.
All right, I got everybody. Yes, Tevin is the only one who got it wrong.
No. That's wrong. That's my bad.
Alpha is positive.
My bad.
Beta is negative.
I just thought I had to it come to me twice later on.
And I believe you.
I ain't mean to.
All right. Last question.
What is that?
All right, this one works backwards, and I just randomly selected this, so hopefully this question makes sense. I didn't actually work it. So see if it get it.
Where is the house?
Move your head.
What's the half-life of an isotope if 25 grams of the original sample?
So we have to work
Yeah,
this
you
out.
did.
Yeah, you got to solve it.
It doesn't make
It is left unchanged after 11.46 days.
Let's try another
Okay.
I just selected it. I don't even know if it makes sense. I just grabbed it out of the test bank that I was using.
I'm tripping. I'm like, E.
I don't know.
Why is it 2 grams? Okay, what's the amount?
I don't even do it.
2 grams.
Oh, child. What is the house life?
What grams do you use?
Oh,
I didn't even try to work it, so I don't even know if it makes sense.
This one I'm
You
saying.
go first. I'll
I
let
can
you.
use, if I can make sense of it, then it's not. Not make no sense.
for me, it's unchanged out there. 11.46 days.
That's the time.
It's 8. So,
Could you just give us a free one? Answer?
wait, so you started out with 200 grams? That's what you started out with, right? Mother, mother. Shoot the hell, right off in the dick. Hold on. So is it, are you just going to 24?
It's like, let's see, ain't probably not.
Got the amount, this half-life. Started at 200, we went to 25.
200, 175. That's 8.
Can you get some right?
The right answer is B.
I don't see how you get that from that. So.
I don't either.
I don't know. Easy.
Everybody just choose B.
I want to know how to get it first.
Just keep dividing?
No, if you keep dividing, you're not going to get that.
Yeah.
I know you've got. I know we have amount. I know we've started with 200. We'd cut it in half. We'd cut it in half. We'd cut it in half. Our time is there, but I don't know how they're expecting us to use the 11.46 days.
Trent, it's B.
What if you cut 11, 24?
Anybody see something I'm not seeing?
I see red.
Well, after you divide by 2 times, you get like 280. You get 286.
I see Trent.
2.86. If you divide that by 2 times. And if you do it another time, yeah, you get like 1.4.
You divide by 0, it becomes 2.
Say what?
You get like 1.6. Because originally what I was thinking is,
Yeah, but it doesn't say the half-life is 11.46 days.
yeah,
I don't know. I don't know what they want you to do there. I don't like that question. Hopefully they don't give you that on the exam.
Did you make that question?
No, I snagged it out of a test bank that I found online. And I didn't work it. I just thought it would be a straightforward half-life question. The answer is B. If y'all want, you can hold it up, but it doesn't matter. All right, if you will, put your Plicker card back up here.
A lot of people got tickets. Because of me. I don't like it.
Are we taking more notes in this fall?
Yeah, we're gonna talk a little bit about acids and bases. We won't get very much, but we're gonna do a little bit. Say what? Who? No, you can make it.
Oh my gosh.
2.5 off in the drink.
Hold on. Monterey.
Stay away from me.
Why? Ease. Can't leave that. Try it. No, wait. Jennifer, what's that? Jennifer, what's that say?
What did you just call me?
Jennifer. I'll ask you. All the best.
What does it say?
We still need the calculators.
No.
Are you being sarcastic?
No, I'm serious.
Me, A. Monterey. And L.
All right, we're gonna talk a little bit about acids and bases with the last half hour of class.
I don't believe it.
This is the last part of solutions that we're supposed to study before you take the exam. And we're gonna hit as many highlights of this as we can as we do review over the next few days. And we really won't get to many. Hopefully out of 45 questions, you will not see more than 2 of these out of the 45. So when you get to these, hopefully I can give you enough that you can at least eliminate some answer choices maybe, so you have a better chance of guessing. Because at this point, that's all I'm doing for you, is trying to give you a better chance of guessing. Because, okay, but hopefully, this is the only stuff you'll see on the exam that you just don't know anything about. Every other topic, we've covered, okay?
So we cover the curriculum.
Other than acids and bases, yeah. We have. Now, How do you recognize an acid? When we talk about acids and bases, there's actually 3 definitions of acids. Traditional and Bronsted are the 2 we're supposed to do. Lewis is the 3rd type, and it's not in our curriculum. So those of you who I've said will go on and study chemistry at another level, there are 3 definitions of acids and bases, and you will talk about all 3 at a higher level if you choose to pursue a science career. Or even those of you who said you have an interest in nursing, even an entry-level chemistry class, your professor will probably make you know all 3 acid-base definitions, okay? The first, and the one that you typically talk about in all science classes, is a traditional definition, and it's also called an Arrhenius definition, okay? So if you see that name, that's the definition we all use, literally on your phone. Now, how do you recognize a traditional acid? Everybody knows this. It starts with an H where? Where's the H got to be? That's back at the front, okay? So in order to be a traditional or an Arrhenius acid, the hydrogen is always first. So if you think about the acids that we've learned this semester, HCl, H2SO4, oops, that 4 looks terrible, HNO3, H3PO4. All right, all of those start with an H at the front. They're all traditional or Arrhenius acids because the H is at the front of them, okay? Any issues with that? Now, can I move on? Okay. Now, you don't need to write these down because I'm not going to give you time to write them down. Some common acids you might see. All right, stomach acid. A lot of you know hydrochloric acid is stomach acid. When you throw up, that burning feeling you feel in your throat is an acid that comes up. It's also the acid that eats the enamel off your teeth. That's why dentists are able to figure out that people are bulimic and throwing up constantly. It eats the enamel off your teeth, so dentists are it's easy for dentists to recognize that. All right, sulfuric acid is the acid that's in batteries, or the acid that builds up around the top of the batteries that causes sometimes your cars not to start because it's got all that corrosion on it and doesn't make a good connection with the battery cables. Clean that off and your car will start a lot of times. Phosphoric acids in soft drinks. Acetic acids in vinegar. My 3's not subscript there. Citric acids in fruits like lemons, oranges. Malic acids in apples. Milk has lactic acid. Some of y'all might be lactose intolerant. Yeah, you are? Okay. Just some common acids. Now, these are the things you ought to write down. Okay? Properties of acids and properties of bases are some things you're supposed to know for the exam. Most of you know acids taste sour. Okay? It's a common property of acids. So when we have soft drinks that have phosphoric acid in them, why don't soft drinks taste sour? They got a buttload of sugar in them to make them taste sweet. Okay? Which is why I like them. Now, acids react with metal. They give off hydrogen gas. So, common example of this. Zinc. What state is zinc? What state is zinc? Okay. Reacts with an acid. What state should I put here for an acid? Aqueous. It's dissolved in water. Okay. It's going to react. What kind of reaction is this? Review for the exam. It's what? Very good. How would we do a single replacement for the exam? If you saw this on the exam, what would y'all do? Switch the 2 with the... All right, so let's find some oxidation numbers. What's zinc's oxidation number? Okay, I heard some right answers out there. Is it one you're supposed to know? Mm-hmm. Who's the other one you're supposed to know in the transition elements? Silver. What's silver? +1. Very good. So zinc's +2. What's hydrogen? +1. What's chlorine? -1. All right. So who's switching? Okay. So zinc's going to be with who? Good. And H is going to be? Very good. All right. So what do I have to do to zinc and the Cl? Oxidation numbers. Zinc has a 2 and chlorine has a. So what do I need to do there? Bring it down. All right. And hydrogen, do I know anything about it?
Yes.
Got it too. All right. Let's put some states in on this. How do I know the states here? Look at the table. All right. What do you know about chlorides? Salma, Bryce, pick your heads up. What do you know about chlorides? All of them are soluble. So you write what? Very good. All right. What do you know about hydrogen? Do I need to look at the orange sheet? What do you know about hydrogen? It is diatomic and it's a what? So you just write G. Questions about that? So what's being given off here according to your property you just wrote right there? So this right here is the gas that's given off. So you will see bubbles that will be given off here when it reacts. Okay? Questions? I just thought I'd throw that in as review since, the exam's coming. All right, number 3, you should have done at middle school. Okay? Every middle school teacher I've ever met does this in middle school. Now, given some of you had subs, you probably did not get to do this, unfortunately. Exactly. That's why I said everybody gets to do this in middle school unless you got a sub. Because every middle school teacher I've ever met teaches acids and bases. The water cycle and acids and bases are the 2 topics they never ever skip unless you had a full-time sub in middle school. Now, acids and bases change the colors of dyes. Okay? So, if you had a real teacher, they had little tiny strips of paper that looked like this.
Oh.
And they gave you liquids, and they let you probably dip little tiny strips of paper and let you figure out if they turn blue or red. They might have even given you little yellowish orange colored strips of paper to see if they turn yellow or red. Okay? No, that's a different kind to see if it's good. Okay, a different kind of paper. Now, red litmus paper. All right? Red litmus paper, if I put it in an acid, what color does red litmus paper turn in an acid? Turns red. Okay? If I put blue litmus paper in an acid, it turns red. Y'all writing this down?
Yes.
If I put pH, y'all are going to see colored stuff somewhere on that test. I would be shocked if you don't see something about a chart with some color somewhere. May not be these colors. It could be a different color for all I know. All right, pH paper. It's going to be red. Now, what pattern did you notice? Acids are all red. Okay? Now, bases turned what color? Bases turned blue. Remember, they all start with B's. B, 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 B. Bases are blue. Now, the organic indicators or the liquids, I just took a shot in the dark. I use phenolphthalein. I have no earthly idea what your middle school teacher might have picked. They may not have used one at all. They may have only used paper. I tend to pick phenolphthalein. There are any number they could pick on the exam. They could pick phenol red. They could pick the universal indicator. They could pick Congo blue. There's anything that they could pick for the exam. Okay? They will have to give you a pH range and tell you what color it's going to change. In this case, an acid will be clear and the base will be pink. Okay? But they are going to change colors based on a pH range. and we'll talk about pH, if not today, tomorrow. Where they turn colors.
Isn't it like?
It would be which one?
X-ray. I mean, yes. Oh yeah, because if you go, yeah.
7 to 14 would be the base. We're going to talk more about which ion falls where in which range. That's the important part for y'all, not the color based on 0 to 7 or 7 to 14. Okay, the ions are the important part for this class. All right, everybody got it? All right, number 4, acids or electrolytes. We just talked about this the other day. What's an electrolyte? That's the piece that's important in this number 4. They make electricity when dissolved in water. Okay, so electrolytes dissolve in water and conduct electricity. So we said strong acids or strong electrolytes. Yep,
Was the chart 3?
yep.
Okay.
Weak acids were weak electrolytes. Does anybody remember how to tell if something was a strong acid or if something was a weak acid? Had to be one of the 7. Okay. So one of the 7 acids made you a strong acid. And if you were a weak acid,
Yeah.
you were all other acids. So if I said HClO4, for example, what are you? Okay, that'd be a strong electrolyte. What about HNO2? It's a weak electrolyte. It's not one of the 7. Also, you can use your H and your O. When you subtract the H and the O, how many O's are there? 2 O's. How many N's? Or sorry, H's. 2 minus 1 is 1. So it's got to be 2 or more in order for it to be strong. Okay? All right, number 5. Everybody got it? Nope, I need to wait. All right, number 5. Acids react with bases to produce a salt and water. Any of you ever have an upset stomach? Heartburn. This is what takes place in your stomach all the time. Acids react with bases to produce a salt and water. It's called a neutralization reaction. Okay? So the example I put up here, HCl, what did we call HCl just a little bit ago? This was called stomach acid, right?
Oh, my bad.
So I put stomach acid up here. Calcium hydroxide, anybody know what that's found in?
Oh, calcium.
Yep, it's found in Tums. Tums.
Oh, yeah.
You know the commercial? Get your daily calcium supplement in Tums. So calcium hydroxide is found in Tums. So upset stomach or heartburn, take a Tums. This is what kind of reaction? Forget what I wrote right there. Double displacement, right? So Ca and H do what? They switch places. So Ca is now with Cl right here. So it's a double displacement. So this is now the salt and water. Now, if you remember the other day, I told you a salt is just an ionic compound. So all that's happening is we're putting an acid and a base together, and it's neutralizing it. Okay, so when you have heartburn, anybody have any parents who complain about heartburn?
What's that?
I do though.
You have it? It's heartburn is nothing more than too much stomach acid coming up your esophagus. It just comes back up through your esophagus. It doesn't stay in your stomach. Okay?
I eat Tums after I eat pizza.
Huh?
I eat Tums after I eat pizza. Makes me sick.
There you go. Now, why is it called a neutralization reaction? Anybody know?
Cancel each other.
It neutralizes the acid, or you can say it levels
That's what I said.
the pH in the stomach. Either one will work, since we're talking about food. Okay, everybody got it? Now, the nice thing about the bases is the first two are different, and the last three are the exact same, so we don't have to write the last three. Okay, so how are the first two different? Does anybody know? How do bases taste?
Bitter.
Yep. Bases are bitter. Bases feel how? Slippery. You can tell when you have them on your hand. Think about soap. Do you know if soap's not off your hands?
Yeah.
Yeah, because it feels how?
Kind of dry. I mean,
If it's wet, it feels how? Slippery. If you've left it on your hands, you're just going to feel dry and sort of scratchy. If you have a really caustic base on your hands, it'll cause a rash over time. Now, you can write 3, 4, and 5 if you want again. I didn't put any details with those because they're the exact same properties again. So bases change the color of indicators. We're not going to draw that chart again because they're the exact same colors. Acids will be what color again?
red.
Red. Bases will be what color? Blue. Huh? Yes. You might have.
What time?
Probably about 7:30.
Oh, yeah. That's true. Yeah, let's go pick it up.
Where's she live?
Do you know where Lamb Road is?
I live off Lamb Road, so yes, you probably did pass me.
Yep. Her road doesn't have a street sign though. She's getting knocked down.
All right, bases are electrolytes, and bases react with acids to produce a salt and water. So the only two that are different are 1 and 2. Okay? Questions? Now, we need to talk about the pH scale, but the numbers are not the important part. We need to talk about the ions. And then we'll pretty much be out of time. And then we're going to spend what we can over the next 3 days reviewing and see what you know and don't know.
I just need to figure out that. Okay.
You know what?
What are the Lewis structures? That's just hard.
Hopefully there won't be a ton of Lewis structures, but I don't know. I don't ever get to see the exam, so I don't know what will be there.
It's like the 45 questions, just all multiple choice, and
That's it.
That's it.
There's no free response on any of the science tests.
Yes. What? Yo.
You have 2 hours to do 45 multiple choice questions.
So that jump out the long.
Most people finish, from what other people have told me who give the test, somewhere between the first and second break. Some people will go after the second break. I don't think we ever go the full time, or rarely.
You know who what we're going to be?
I'd have to look. All right, so the pH scale, let's finish this up. So from 0 to 14. Now, just knowing where the acid is and where the base is not the point of the chemistry class. That's not going to get you very far on the exam. Might help you eliminate something, but it's not going to do a lot for you. All right, so from 0 to 7, you know that's an acid, right? 7 to 14, most people are going to remember that's a base without a lot of difficulty. And 7, most people are going to remember as neutral. Now, we need to at least talk about which ions go where. There's a whole bunch of calculations that go with this. There's actually 6 formulas. We didn't get to this, which is why I said I hope you don't see more than 2 questions on this topic. Now, if you're an acid, you're going to have the hydrogen ion. If you're a base, you're going to have the OH ion. Okay? Now, the OH ion's name is what again? OH. What's his name? Hydroxide. Okay? So if you don't know that, its name is hydroxide. So if you're a base, you're going to have hydroxide. If you're an acid, you're going to have hydrogen ion. Now, the more hydrogen you have, the more the acid you are. The more hydroxide you have, the greater the base you are. Okay? Does that make sense? So, in order for us to be neutral, what can you tell me about these two ions if we're neutral? They're equal. Okay? So, for us to be a pH of 7, all right, our hydrogen ion must be equal to our OH ion. For us to be neutral, those two things have to be equal. Nowhere else on that pH scale are those ions going to be equal. Does that make sense? Now, everywhere less than 7, what can you tell me about the hydrogen ion? It's more, okay? So down here in the red area, we have more hydrogen ion. Where's the hydrogen ion going to be the absolute greatest in this area? 0, okay? At 0, you have the most hydrogen ion. So that means you're going to have the least OH ion. Does that make sense? Okay. So, on the scale, where would we have the most hydroxide ion? Okay. So on this scale, we're going to have the most hydroxide ion down here, and we will have the least hydrogen ion there. Are you with me? Now, if you look on your formula sheet, can you find that real quick? Your orange reference tables. On the very bottom of that formula page, okay, at the very bottom, there are multiple formulas that say pH equals, there's one that says POH equals. The page has got all the formulas, okay? They're all at the bottom. There are, let me see how many. 1, 2, 3, 4, 5, 6. It's the bottom 6. All right? Those formulas go with this scale. All right? We'll try to get a couple of these in here over the next couple days. I can't make you any promises, but we'll try. Now, with the remaining time that I have,